Imagine a computer that can solve problems so complex. Today's supercomputers would take thousands of years to even begin. Sounds like science fiction? It's not. Welcome to the world of quantum computing, where physics meets computation and the impossible starts to look possible. In this video, we're going to break down the key concepts, real-world applications, and future implications of quantum computers, all in just 10 minutes, without the confusing jargon. Classical versus quantum, beyond bits. To understand quantum computing, let's start with what we already know. Every computer you've ever used, your phone, your laptop, even the most powerful supercomputers, process information in bits, zeros, and ones. Each bit is like a tiny switch, either on 1 or off 0. Millions and billions of these switches combine to run programs, store information, and perform calculations. Quantum computers, however, don't follow these classical rules. They operate in the quantum realm, where particles behave in ways that defy everyday intuition. The difference between a classical processor and a quantum processor is like the difference between a flashlight and a laser. Both produce light, but one is scattered. The other is focused and powerful. Quantum superpowers, qubits, superposition, and entanglement. Meet the qubit, the quantum version of the bit. While a bit can be 0 or 1, a qubit can be both at the same time, thanks to a phenomenon called superposition. Imagine flipping a coin. While it's spinning in the air, it's not just heads or tails, it's a combination of both. That's what a qubit does until it's measured. Now, take things a step further with entanglement. This is where two qubits become linked in such a way that the state of one instantly affects the other, no matter how far apart they are. Einstein called it spooky action at a distance. These two properties, superposition and entanglement, give quantum computers their mind-bending power. They can explore many possibilities at once, allowing them to solve certain problems exponentially faster than classical computers. So why all the excitement? Quantum computers could revolutionize entire industries. They could simulate molecules for drug discovery, design new materials, optimize global logistics, and even crack modern encryption methods, forcing us to rethink cybersecurity. But building these machines is not easy. Qubits are incredibly delicate. They need to be kept near absolute zero in specialized environments to prevent interference from even the slightest vibration or heat. And because they're so sensitive, quantum computers are prone to errors, which makes scaling them up a major engineering challenge. Real-world quantum. Who's building it? Despite the challenges, the quantum race is on. Tech giants like IBM, Google, and Microsoft, along with startups and research labs, are competing to build the first practical quantum computer. There are different approaches. Superconducting qubits, used by Google and IBM, trapped ions, which use charged atoms, and more exotic methods like topological qubits, which aim to reduce errors naturally. Governments are also pouring billions into quantum research, recognizing its strategic importance for national security and economic leadership. Your quantum future, what's next? We're still in the early days, often called the noisy intermediate-scale quantum era, meaning our machines are powerful, but error-prone. Over the next 5 to 10 years, expect to see hybrid systems emerge, quantum processors working alongside classical computers to tackle specific high-value problems. Eventually, As error correction improves, we'll reach fault-tolerant quantum computing, unlocking their full potential. Quantum computing will change fields like AI, climate modeling, finance, logistics, and medicine. And whether you realize it or not, it will likely shape your digital future. Quantum computing isn't just about faster computers. It is about a new way of thinking. We're entering a frontier where physics and information merge, and the possibilities are endless. If you enjoyed this 10-minute primer, make sure to like, subscribe, and explore more deep dives here on How True, where we explain big ideas simply.